Good morning, friends. We are going to discuss about another important domain of understanding, that is related to pattern materials, because these pattern materials also have a very important role to play for different form of casting and their applicability. So from the title slide itself, the pattern is manifested with their typical configurations of those pouring cup, sprue, side risers, the gate, casting and all those top riser part of it. So we will be discussing at length of those things. This is the diagram of sketches of a typical pattern with gating and risering systems. Two things are important, one is riser and another one is a runner. Side riser placed in the sides, top riser placed in the top, and riser is nothing but the reservoir of the molten metal, and riser will solidify last. It is going to ensure the supply of the molten metal, so that in intricate part of it, the nook and corner of all those cavities are not hungry of molten metal. That is the purpose of the riser. And runner, through runner, the main channel with the molten metal will flow to different part. So runner will ensure where voluminous material has to be transported into the different part of the cavity, and riser will be put into the appropriate places to ensure that it is acting as a sensor, so that it can sense that in those part of the cavity the molten metal is already there, so it is not short casting. And pouring cup will ensure that the turbulence while pouring those molten metal is attenuated, so it is a typically linear flow with the sprue, and it is entering into the channel, less turbulence, because if the more turbulence will be there is a possibility of the damage of the internal part of those mold, which is not of a very high strength, because these are all made of the sand and other part, so that turbulence is minimum, so the rupture and distortion of the intricate cavities are less, and the possibility of defective casting is less. That is the main purpose of having these configuration. And from runner to the main casting cavity is connected by gate, so that appropriate entry of the molten metal should be invited into the cavities appropriately, without any turbulence, without any other kind of hassles. The function of the pattern we have already discussed, and to emphasize it further, that a pattern prepares a mold cavity for the purpose of making a casting. Male part is always easier to make than the part of the female cavities. So it is too easy to give the shape in the intricate part of it, and then use that male part in order to generate the cavity in terms of those sand. And once the cavity is there, it is good enough to absorb those molten metal and give those complex shape conjugate to the pattern part. A pattern may contain projections as known as core prints, and if the casting requires a core and need to be made hollow, in many of the cases we want an hollow part of those components, so no point in make a solid part when we have to make it hollow. So cores are used in order to ensure there is appropriate hollowness, so that the machining possibility is less. Otherwise solid part can be cast and then we can go for the machining, but problem with the machining is that it is an extra hazards. Extra hazards will have to be there, and cost and other kind of implications in order to make those hollow sections. Sometimes the materials are also not accessible, geometry is not accessible for those machine tool to enter into to make a hollow part. So it is always a good thing to make use of core to make a hollow part. It is a very intelligent and decent process of making the hollow section. And the runner and the gates and the risers used for feeding molten metal into the mold cavity may form a part of the pattern, because pattern will also make all those things of runner, preparation of the runner and the risers. So those things are also made by wooden pattern, though it is not part of the exact part of the casting, but they are necessary supporting accessories related to the casting process, and they are also made by the pattern. And pattern properly made and having finished and smooth surfaces reduce casting defects, because casting will be produced as per the pattern, and if the pattern's surfaces are smooth, we cannot expect very good smooth surfaces of the casting. So pattern has to be made with appropriate surface finish to produce the quality casting. A properly constructed pattern minimizes overall cost of the casting. The reason is that then you have to do less machining, less defects, less uncertainties, better surface finish, and all those things lead to the system where the quality of the castings and other things are much better. So one has to emphasize those accuracies, surface finish, the dimensional accuracies and other things are appropriate level in order to get a good quality casting. The pattern, the features, the pattern is the principal tool during the casting process. A casting is as good as its pattern. A captain is as good as his team, so that is also casting is as good as its pattern. The pattern is defective, the pattern is not proper, definitely we cannot expect the casting in one go should be proper. Many post processing has to be done if the pattern is defective, and sometimes the casting is totally rejected because of the defective pattern. And it is the replica of the object to be made by the casting process and with some modification. But it is not exact. The reason is that there are some uncertainties in casting process, different kind of shrinkages, different kind of allowances and other things has to be provided in the pattern, which is slightly different from the actual dimensions of the casting. So there lies the expertise associated with the pattern making practices. So with some modification has to be there, because many of the cases the designers will specify the object, but designers will not specify what kind of pattern will be most suitable in order to make that thing. So that kind of analysis of those designs in terms of manufacturing has to be carried out by the people who are related to pattern, and in many of the big casting houses there is a pattern making shop where people are very much experienced and expertise in pattern making, and many woodworking tool they are utilizing in order to come out with a very good and effective and appropriate pattern. So the main modifications are the addition of the pattern allowances and the provision of the core prints. Pattern allowances are many and they are tricky. They are geometry specific, the casting metal specific, and many knowledge bases are associated with that, and very costly software can simulate some part of that, not in totality. So many human expertise is needed in order to ensure appropriate kind of pattern allowances based on the historical data of pattern making and subsequent casting process. If the casting is to be hollow, additional patterns called cores and these cavities in the finished part, we have to create all those things, and how this will be placed, and that is also an issue. People are using some kind of pins, them are using some kind of chaplets, so that those cores are in hanging condition, and these chaplets are self-sacrificial, so they will melt with this casting without having much of the effects in terms of quality, but in the meantime the core will be placed appropriately so that the hollow sections is accurate, and that is the implemented one. The quality of the casting product depends primarily upon the material of the pattern, its design and construction. different classes of material we can use, and the cost of the pattern and related equipment are reflected in the cost of the casting. If the pattern is very costly, then definitely the casting process will be in totality very costly. Like say if we use sacrificial pattern like wax pattern that is used in investment casting, it becomes a costly process, because every time we have to sacrifice the pattern, and every time the making of the cost of the pattern, the casting has to bear with. So then cost will shoot up. Though we can generate very high quality of casting, investment casting, but the problem, the cost of the pattern making will shoot up, because every time we have to make the pattern. So this is why these processes called sacrificial pattern based casting. The use of an expensive pattern is justified when the quantity of the casting is required to be substantial. If we want to do lot many dimensionally accurate, and only justified for mass production. If we do lot many implications in terms of manufacturing uncertainties with the pattern, another part of it, and it is if a small size production, definitely the cost, the effort to make those patterns are not justified. The core print also important, and this is nothing but the part of a foundry pattern which it makes opening in a mold to receive a core and to support it while the metal is being poured. Somebody has to put a red carpet for the core itself, and core print is just to doing, it is a necessary strategy to accommodate those cores, and which is responsible for the creation of the hollow part in a casting. The pattern can be made out of various materials. Options are different. Some of the materials used for making patterns are wood. Wood is a cheaply available material, but now the cost of the woods are shooting up. Previously, wood is a very good handy material and easy to give shape. That is the beauty of wood. Some cases of the mass production or higher batch production, people are using metals because the advantage of the metals is less wear and tear. The problem with the wood is its dimensional changes in different seasons if it is not a seasoned wood, and wear and tear and jeopardy of those surfaces and other things are issues in wood. Wooden patterns have less lasting life. And some of the alloys are also used to get the advantage of the different combination of the metals. People are using plastics also, because the plastic is very easy to manufacture all those plastic at lower cost. People are using plaster of Paris also, easy to give shapes of all those plaster of Paris. Then plastic and rubbers and wax and resins. Many things can be used. Wax is used in case of investment casting as a sacrificial pattern, and now with the advent of the 3D printing technology, rapid prototyping technology, advantage is that wax pattern can be 3D printed, and 3D printing has a tremendous advantage that it is not very much operator specific. Once we can have a good CAD model, we can print the pattern with its initial dimensional inaccuracies and surface finish. But the problem of the hassles of manufacturing those pattern is minimum if we are using the 3D printing technology, and wax pattern also can be produced by 3D printing technology, and resins also in some few cases. Every material has its own advantages and disadvantages of being used as a pattern, and that is why there is no universally accepted material, one material for all patterns. The answer is no, because some application, some is better suited than that of the other. So application specific, frequency of production specific, geometry specific, according to that the pattern materials are cost specific, pattern materials are selected. So we can see from the tabular the pattern materials, the main predominant materials are wood, age old pattern making materials, then metal, then plastic, because of the advent of the plastic, easy to give shape, all those things. The plaster of Paris, the gypsum plasters, easy again to give shape, again the cavity will be there, and those cavities will be used in order to make those pattern of plaster of Paris. And last but not the least is the wax, tremendous applications in investment casting. Now one can print those paraffin wax and beeswax or any other kind of wax, and these are all most popular pattern materials. Characteristics of good pattern materials are, in general, the pattern material should possess the following characteristics. One is easily worked, shaped and joined. Machinability of the pattern is utmost important, because if a lot of hazards are there in order to machine that pattern to generate intricate shapes, the purpose of the advantage of the casting is lost. We are doing casting because producing that kind of component is tricky, is challenging. That is why we are going into the shorter route by creating the pattern. If the pattern material is equally difficult to machine another part, then definitely it is not a great idea. So people thought of those kind of machines where easily can be machined, machinability is high, easy to give shape, easy to join, and those things. The second one is light in weight, because one has to handle the pattern. If it is bulky and weight is great, the problem is that handling it will be hazardous. Productivity of all those casting process will be less. Very difficult to put all those appropriate places, putting all those things and handling of those pattern. The third one is strong, hard and durable. If the pattern, because lot of use and other things, if the strength is not great, there will be dimensional distortion, wear and tear of those pattern. It has to be hard. Hard means against the wear resistance, and it has to be durable, because there are some costs associated with that. If the life cycle is extended period, the pattern cost in case of per casting will be less. But if it is not durable, the casting process becomes expensive. Resistance to wear and abrasion, it is already told that if it is wear means unintended removal of material, and if those materials are removed, the dimension will be the casualty. So people don't want that wear and tear, because less. One cannot have absolutely the elimination of wear, but definitely some part of the wear will be there, but only the strategy should be the minimization of wear and abrasion. Resistance to corrosion, it should not be very much chemical active, specifically where there is a possibility of the chemical reactions. We need dimensionally stable, because once we made it out, we want to take the advantage of that pattern a couple of times or many times. If it is dimensionally not stable, it will produce inaccurate castings, and that is a big headache. And it should be unaffected variations in temperature and humidity. It should be having less alpha value for thermal expansion in change of temperature, and humidity also, because sometimes wood and other things absorb humidity, their dimension gets changed. So that is also not a good option. So it should be robust enough so that its dimension is not changed in humidity. And the seventh one is at available cost. It cannot afford to have very high cost. Only when it is affordable, when the people are ready, consumer is ready to give the price of the costly one. So one has to be very cautious, very judicious in terms of selecting a pattern material of bearable cost. Seasoning is a very important process. Seasoning is the process of drying timber to remove the bound moisture content in the walls of the woods. Woods contain moisture. It was once upon a time living material, so living material has to deal with water, and so has wood. And even after the death of the tree, wood are really storage, have the micro storages of different kind of moistures, and that moisture has to be removed for the seasoning process. Why moisture has to be removed? Because the moisture will be dried up in the long duration, and whenever the moisture will be dried up, it will have its dimensional distortion, and that is the last thing the casting people want. So dimensional distortion has to be minimum, and that is why the seasoning wood has to be there. So the seasoning wood, it can be natural seasoning, putting into the heat and dust in open for quite some time, so that inherent those intricate microstructures where the water and molecules are present, they will be dried up that is known as natural seasoning. Heat and dust and all those temperature variations, directly it will interact with that and make those casting, they make those pattern material, wood material very robust, free from those moisture. And then if the shaping and all those dimensioning is done, the dimensioning will be more stable than the unseasoned wood. So it can be achieved by a number of ways. It aims to remove water at a uniform rate to prevent damage, because presence of water is making it dimensionally unstable in the longer period of time. So you can find all those cleans and drying process where those woods are kept there, and with the trolley, with the roof and other part, it is natural seasoning maybe. So some stress relieving operation also can be done because of the inherent stresses and other things can be removed. So the stress relieving is the treatment of a metal. Stress relieving is associated with the metal. It is a treatment of the metal to a predetermined temperature below its lower transformation temperature and then cooled by the air, so that the internal stresses, grooving up stresses or machining stresses will be removed to a great extent, and then it will be dimensionally stable after machining. So stress relieving is to relieve all those inherent stresses, and it can come out of the forming, stretching, machining or rolling and other things. There will be, sometimes it will be manifested, so better the stresses of those raw materials should be removed at an early date. Advantages of metal pattern. Metal patterns are durable. They undergo very less abrasion because metal is hard enough and abrasion resistant. Wood is not that abrasion resistant, so they are used for large quantity of casting. Whenever the volume of casting is great, we have to use, and wooden pattern after some use it will lose its dimensional accuracy. That will not be lost by the metal patterns. In those cases, metal patterns are the best choice. Smooth surface finish, very good, easily we can give surface finish on the metals. In woods, because of some granular structure, sometimes the surface finish is not an easy option to generate, and sometimes erosion will lead to many roughness in these wood pattern, and that may not happen in the metal patterns. Surface finish can be given to the pattern in metal, do not deform while in storage because of the strength. Where stronger, it is not easy to deform. Closer dimension tolerance, when the surface finish and accuracy of the dimensions are there, definitely it will participate in close dimension tolerance implementation, and because of its inherent metallic strength, it is of high strength. But there are definitely, then all the patterns are, why not metal? The reason is that there are disadvantages. Metals are more heavy in weight, it is not easy to handle. If the workers feel a lot of pain in order to handle, their productivity will come down. Productivity is a very important thing. Productivity will determine the cost of the product, and because of the handling of all those things, a strenuous handling will be there, then definitely productivity will be less. And they are expensive compared to many pattern materials. In many of the down, previously wood was less expensive, now woods are becoming more and more expensive. But metallic patterns in earlier days is very expensive, and if you can find it out, all the rust free metals and all those things, then they are really expensive. Then pattern should be take care to avoid any damages like corrosion and deformation. These kind of surface phenomena will challenge the dimensional integrity of a pattern. So to avoid the corrosion and deformation has to be critically monitored. The main advantages of wood as a pattern, that its machinability, easy to give shape, and it has very, very low weight as compared to the metal pattern. So that way it is easy to handle and easily shaped. Wood is optimal for very large casting and small quantity production. Even the bigger structures also can be formed by the wood, and the advantage is that bigger structured pattern will be easy to handle in comparison to its metallic counterpart. And one of the disadvantages of the wood pattern is the distortion of the dimension due to absorption of moisture. That is a big inherent perennial problem of wood. So seasoning wood has to be used, and sometimes seasoning wood also cannot give the terrific stable result as it can be obtained by conventional metallic pattern. Wood material is not high accuracy in dimension, sometimes it is not, and absorbing moisture dimension is distorted. This material should be handled with care and smooth because there are jeopardy of corrosions and erosions will take place very fast in comparison to metal pattern, so that is utmost care is required. It has less wear resistance because it is not that way hard, so if any abrasive material come in directly contact with those wood, it will lose its luster, surface finish and dimensional accuracy. And wood also has obviously some less abrasion resistance. So, under the vicinity of those hard materials and interaction, the material loss of the wood is inevitable. So, plastic patterns also, sometimes people are using plastic patterns. The main advantage is that it is cheap and light, less expensive. So, the cost of the products will be less, and then definitely the consumer will purchase it in a rapid way because of the cheap cost. So, they are cheap plastic and light also because you can play with the properties and you will select those properties which will not increase its weight. Durability and formability, some plastics are very hard and long lasting formability will be there. Many of the plastic components throughout our life is associated with us. The reason is that the durability and formability, because of the injection molding process and all those processes, immediately it can be formed without much hassle. So, the formability is terrific in comparison to wood and also for metal. And plastic patterns are dimensionally stable when compared to wooden patterns because some mix are there, so make it hard and they become really dimensionally stable, and on the basis of that they are the good candidate for the casting process. So, advantages of plastic pattern: good surface finish. We can use those dye in order to give very good surface finish. Possess good compressive strength because we can play with those plastic materials and we can easily increase those compressive strength, corrosion resistance to chemical, and they can be cleaned easily. All those things are there associated with the chemical properties. This is in favor of casting. And disadvantage is definitely there. Plastic patterns not useful at high temperature. Temperature sensitivity, temperature related things, it is really sometimes very uncertain. So, plastic patterns are not useful at high temperature because it will melt itself. And stronger plastic materials are more closely to see. So, always people have to put into their eyes in the market, international market, and find it out that how the stronger plastic materials will be available there, and one has to get that for their purpose of delivery. Plastic patterns are not useful at higher temperature, obviously, because plastic melting point is not great, though the melting point of liquid plastic can go beyond 1200 degrees Celsius, but beyond some stipulated date, but the plastic patterns are primarily not useful for high temperature applications, and stronger plastic materials are more costly to use. Whenever we go for the strength, we need some kind of molecular assessments in terms of intermolecular space and their bonding, and that will provide the faculty strength, provide those things as strength. Stronger plastic materials are most costly to use because lack of money and unnecessary investments, another part which is not possible sometimes for the people who are using the casting process. So, works pattern, one can see the works pattern. It is a multiple products will be manufactured with works pattern, and this is the tree. Tree is the backbone of those pattern configuration. The pattern of works and all those things will be there. Creamy pouring cup that will kill the dimensional uncertainties, and channelized with a low Reynolds number, and that will enter through those channels easily, and according to the system then casting is done, and very precision intricate casting parts can be manufactured by this method. Jewelry works pattern. The jewelry items, another part of it, the ladies and girls are very fond of those jewelries, and very specifically they are intricate shapes. Shapes will bring some peculiarity, some novelty, and some aesthetic appeal, and that is why we require some casting process which can produce these kind of products. So this is the works pattern. This is the works pattern, intricate and complex, and also these pattern can also be 3D printed. So when 3D printing, the job becomes much easier in comparison to the age-old processes. So this is the trees of associated with those works pattern, and it will be done in one go, many products, and that will be manufactured, and those things will be done with the subsequent steps. We have discussed about all those different pattern materials and their utility part of it in terms of application, in terms of the geometries, and last but not the least, we have seen the works pattern which is responsible for producing intricate surfaces related to the manufacturing of all those ornaments, aesthetic things, intricate shapes, another part for typical application. The quality of the surface quality of those products coming out of this investment casting process is tremendous, and surface finish is great. But only problem is that it's a sacrificial pattern based casting. Every time pattern has to be sacrificed, and because of that sacrificial pattern, the cost of casting will be high. Only and only when economically viable, justified, people go for investment casting. Everybody is not going for the investment casting, because that has some extra cost because of its characteristic process. That's all. Thank you once again for your patient hearing.